Chapter, we're going to introduce chapter 27. This is a very important chapter, okay? And we will be speaking about the batteries, resistors in series and parallel. We'll be speaking about Kirchhoff's laws, and we will be also speaking about RC circuits. So these might be simple for electrical engineers, but not so simple for other people in or other students in other disciplines. Okay? So we have spoken about batteries, but we never mentioned that they are called EMF. A battery or an electric generator or a solar cell, they are devices that maintain a constant potential across them, at least for some period of time, and then they degrade. These are called EMF devices. Very strange name. Okay, EMF means electromotive force. Okay, so EMF is an outdated phrase which stands for electromotive force. Okay, so I don't know why they stick with this. Usually they use batteries, but they are called EMF, and the symbol is given is E or epsilon or whatever. Okay, the EMF is of a battery is actually the maximum voltage that it can give, and this voltage usually decreases with time. So if you have an alkaline battery 1.5, it's not going to stay 1.5. After some period of time, it will go down. But in our problems, we will assume that they provide a constant potential difference. Okay. So a battery is most of batteries are chemical batteries. Okay, but you can have other batteries like, for example, photovoltaic cells and so on. So the chemistry of the battery causes a net flow of positive charges. So usually you have an anode and a cathode. So these are called electrodes. The positive is usually called anode. The negative is called electrode. So this is a positive charge, positive electrode of a battery. This is, think about it as an alkaline battery. And this is a negative electrode. And so you have a solution inside. This solution has a property that there is ionic flow from the cathode to the anode. So they have positive ions flowing in this battery, and this flow of positive ions causes a positive charge, a positive terminal in one side, and a negative terminal on the other side. So this is a negative terminal here and a positive terminal. And what happens if you connect it to a resistor or you connect to a circuit, you will have a current flowing. So you will have electrons. So the electrons will be moving in this direction, but actually the current is moving in the opposite direction. Remember, we said the current is the flowing in the opposite direction of the free carrier charge, which are electrons. Okay, so this is a battery. This is a positive terminal of the battery. This is a negative terminal. Inside the solution or the inside the battery, we have ions are flowing. And they are flowing in the direction indicated here. And outside the battery, we have current. The current is flowing from the positive terminal towards the negative terminal. So if you have a resistor, this is a symbol for a resistor, the current is flowing through this resistor. Okay? So inside the battery, we have a flow of ions. Outside the battery in the circuit, we have a flow of free electrons. And the current is actually flowing in the opposite direction of the electrons. So here, the electrons really are flowing in this direction. Okay, so this is what we call an EMF, and usually we use a symbol, so epsilon, or and we can indicate either the positive terminal and negative terminal, and sometimes in some books they even have an arrow. The arrow is pointing from the negative terminal to the positive terminal of the EMF, or of the battery. Okay? All right. Let me see. I don't know why my mouse.